So from this one curve, you can determine a lot of information. But the most important one was the background ozone that is brought into the state of North Carolina. We did an entirely different experiment, which is, here is a tower. Can anybody guess how tall that tower is? This tower is a little over half a kilometer tall. This tower, from here to the top, is a little over half a kilometer tall. Okay? And this is located in the southeast of Raleigh. Okay? And we instrumented this tower for ozone measurements. So we made measurements of ozone right up there, here, here, and here. Believe it or not, but we did it. Okay? In the name of science. Okay? So let's look at this. So this is measurements made at the top of the tower, 433 meters, little below the top. And this is ozone measurements made at the surface of the tower. Between 0 and 4 a.m., that is early hours of the morning, and this is between 11 a.m. to 4 p.m., middle of the day, when you form the most amount of ozone. That's when the top and the bottom are decoupled atmospherically. There is a planetary boundary layer that decouples the top from the bottom. So what is happening up there will not influence what is happening on the surface. And so if you extrapolate this line, what do you get? 30 parts per billion. Two entirely different experiments led to the same conclusion, which is the background ozone value coming into the state of North Carolina is 30 parts per billion. That's the regionality of ozone. Now let's look at some modeling exercises. So here is an integrated assessment, and that's what we have to do, is to look at ozone in a very holistic way. To do that, we need to know all the emission sources for the precursors. We need to know the chemical transformations. We need to understand the transport, and then examine exposure, damage, and evaluation. And that's the model was published by a student of mine in environmental science and technology. So you look at the meteorology, which is the transport-related issue, how the meteorology moves the pollutants around. Emissions of the precursors, NOx and VOCs, the chemical transformations that you determine in the laboratory, but you feed it into the model, and out pops the ozone concentration, and then you look at exposure and socioeconomic and on and on and on. And so these models are used, and here is a video that takes us from August 14th to August 17th. August 14th will come in a minute. That's when the ozone started, maximum amount of ozone. As you moved into August 15th, the ozone became slightly more, but by the 16th and 17th, so we now have sophisticated models that allow us to examine the ozone concentration in a very holistic way. Here is a similar model, sample air quality forecast guidance. And indeed, now the federal government, more specifically US EPA, has started to predict ozone, much the way we predict temperature. We are now able to predict ozone, i.e. the air quality. And so we have an ozone problem here, that's right there in North Carolina. Atlanta has a serious ozone problem. And so if you look at this in a little more magnified way, this is where we are. So mathematically, through modeling exercises, we can indeed show that there is an ozone problem in the region we are here today. And similarly, there is an ozone problem in Atlanta, which is this. So we can do county by county by county. We can be very fine in our evaluation. So what are the issues that we have to deal with as it relates to ozone? There is a well-known non-linear relationship between ozone and its precursors. Precursors being oxides of nitrogen and volatile organic compounds. It's not simply a linear relationship. It's a complicated, non-linear relationship. These emissions are unevenly produced. There's more produced along the highways, less produced as you go inland. There's changing meteorological conditions, which changes the transport issues and the chemistry issues. And lastly, there is uneven distribution of population, so the exposure to the population. So these are some of the issues that we have to deal with. So let me conclude by some take-home message. Ozone pollution is not a local problem, as I have attempted to point out. In North Carolina and most US states are influenced by out-of-state NOx emissions, which then leads to background ozone value. Regional controls of NOx is necessary to be able to arrive at ozone concentrations as mandated by the Clean Air Act. The ozone precursors, that is NOx and VOCs, their effects vary across space. Ozone damages vary within a metropolitan area, depending on the kind of population, the size of population, and the like. However, let's not forget, against traditional wisdom based on chemistry that has now been developed, and that's relatively recent, NOx could be your friend of convenience if emitted at the right time at the right place, because NOx will react with ozone to titrate the ozone out, and there'll be no more ozone left. So that is somewhat of a, but that cannot be a control strategy. That is merely, it can be a convenience choice. And lastly, the statewide air quality considering ozone continues to improve versus both the old and the new ozone standard, but in the Triangle area, the Triad, and in the Charlotte, we are not there yet. And lastly, what is it that we can do?